Thanks for coming, everyone. Super excited to have the only JavaScript, TypeScript talk here today. So strap in. It's going to be a fun one. Usually when I give a talk, I like to go back and look at some historical things that went on, especially in Ethereum. Everything changes very quickly. And in the JavaScript world, there was this talk by Nozensmeister of Uniswap fame, where he was talking about like building apps at an ETH Global event in New York in 2019. And modern back then, according to him, which getting definitions from other people is always the move. You don't have to define stuff on your own. dApps being like very responsive, feeling alive, like being, they're connected to blockchains, so having really good data and in your apps, making things feel up to date is really good for UX, really good for correctness. Like you click a button, you get a quick response, stuff like that. So that's kind of like the frame in which we're going to view everything we talk about today. And so the reason I decided to talk about modern JS stuff is we're getting close to the end of 2024. We're at like a conference that focuses on high performance bleeding edge software. So I was like, okay, what's bleeding edge today in the JavaScript world for Ethereum? There's no better way than kind of taking a look at some history. I think the history of technology is really important. When we build tools, it's really nice to understand the context of where things have been in the past. It helps you measure progress between different iterations. And maybe most importantly, that someone said last night, if you don't respect your house, it will fall on you. So you can try to figure out who said that. I just think it's really cool to look because a lot of the trends are the same. Like if we think about cars, it's like these are both like supercars at the time. The one on the top was like the best, but obviously no longer. But it still has a lot going for it. A little disclaimer: this is not going to be comprehensive. I sort of like got involved, joined Ethereum in like late 2020. So a lot of the historical stuff, if it was still around by then, I like have used it. But a lot of the things that were, like 2014, 2015, like the back catalog, maybe some of you have experience with, but I unfortunately wasn't able to play around with that stuff directly at that time period. And if I missed something, super down to, hear more about it. Probably not in the Q&A like I put down here, because they have to be questions, not statements. But I would love to chat, learn more about everyone's experience. So let's turn back the clocks real quick before we jump forward into the present and talk about modern day. April 2015, Web3.js had its first major version. I'm sure a bunch of people have used Web3.js, whether it was in 2015 or more recently. Something that's really interesting with the context for Web3.js is that, while it was released 2015 April, the first commit was back in like September 2014, which is wild. Ethereum wasn't in production yet for mainnet. TypeScript, hadn't even had a first version yet. Like the first commit for TypeScript was like July 2014, if I'm remembering correctly. So like very different world that this project was started in, which is really interesting to see where it's come to today. I guess next on this tour is something called EtherSim. Has anyone used EtherSim back then? Or not super surprised. But EtherSim was really important because it kind of laid the groundwork for like a lot of future things. EtherSim was like a JSON RPC library you could use for testing or like in development, just kind of like test your changes in JavaScript. And this kind of evolved further, Truffle Suite came out of here, Ganache came out of here. So really cool that people were thinking about that, not too long after Ethereum launched there. And then, cut forward a couple years, Ethers.js, I think, was like a pretty big improvement on like the Web3.js of the time. And even if it wasn't, it was a different API, it was a different approach to problem solving, introduced things that were pretty interesting, like human readable ABIs and stuff like that. Performance was improved. And then on top of that, there was type chain, which, TypeScript has been around for a few years at this point, and there's like, a bunch of JavaScript developers are starting to realize that strong types are, pretty great. And so type chain made it a lot easier to then take your ABIs with your contracts and then spit out like a typed SDK, which then you can use to, call whatever functions or listen to events. And, it introduces like a degree of precision and correctness that didn't really exist in the JavaScript world before. And especially with Ethereum, it's kind of dangerous. You might pass like a value that is, a much larger value than you want for a number and transfer things incorrectly. Yeah, in 2018, maybe building on some of the things from EtherSim, Biddler comes out. Has anyone used this before? Oh, nice, we got one person at least. Yeah, and this was, I think, pretty important improvement for developers. It was like, you could start building smart contracts and you didn't have to like compile stuff on your own. It was like a whole framework built in JavaScript, a precursor to Foundry in many ways. And Builder will like come back up here in a couple years down the line. Web3 Webpack is like our first foray maybe into like more front-end like app-specific related tools. If you're not familiar with Webpack, it's like a bundler for the web that allows you to like take some code, maybe it's like JavaScript or TypeScript or like some assets, SVGs, and then like spit out like a built bundle that maybe like transpiled the TypeScript to JavaScript or like minified the SVGs or some other stuff. And so Web3 Webpack was a way to like hook into Webpack projects at the time and have like an Ethereum provider you could use. And a lot of this, I guess the order of this, they came out around the same time, but EIP 1193 was really important along this journey because, it took like this chaos of like people shoving providers onto window.ethereum and kind of like standardized what an Ethereum provider API could look like, which then allows people to build a lot more cool things like Wallet Connect kind of like came out around the same time, which is again like I think a lot of people take it for granted today, but I take it for granted today because I wasn't around pre-Wallet Connect, but it allowed you to like bring mobile into the equation, and yeah, it was like a pretty big step forward. Wallet Connect widget now is called Web3 Modal, but this was kind of like the first attempt at a Connect Wallet modal, which like I think you start to see like people get more into like the UX side of crypto. Clevis and Dapparatus, has anyone ever heard of these tools? Yeah, you probably didn't because I made them up. I'm just kidding, I didn't, they're real. No, but these were like really cool tools. I wasn't aware of these until I went digging back through the history. Clevis was like a way to like run like a node and like do a bunch of like changes to that if you wanted to like go in and change like the gas limit or other type of stuff. And Dapparatus was like higher level components that you could use building like a React app or something. So Web3 Webpack becomes Web3 React. Noah Zinsmeister from earlier worked on Web3 Webpack, kind of formalized it more into Web3 React as like work on Uniswap, like the OG, or like one of the most well-known dApps was getting worked on. And Scaffold ETH is kind of like this iteration on Clevis and Dapparatus, which I think a lot of people, me included, like would get started with at like a hackathon or just like as a quick way to get building. Biddler becomes hard hat, and so it's really interesting. You kind of see like initial versions of these tools get released because there was like a need. Someone needed this functionality to build. And then you kind of see them, like, a bunch of people use them because there was nothing that existed. They're a really good boon for productivity. And then you kind of see, like, maybe like a year or two later, like another iteration on top of them. You learn all the mistakes that you made in like the first version of the API. And hard hat, I think a lot of people got started on it. Works really well at the time for like forking networks and stuff like that. And so this is kind of like what the 2020 frontier looked like. Got a couple JavaScript libraries for doing lower level stuff, which is nice to have options. Maybe you don't like, how one thing does something or there's a bug. You can fork mainnet, which is really great for quick iteration and development. With type chain, you can code gen types and you get like all the benefits of TypeScript in that way. You can hook into React, which is important for building apps. Yeah, you have like a Connect Wallet modal, so you can get started. You don't need to build that stuff from scratch. There's like a bunch of quick start stuff in the ecosystem where you can get really quickly started at a hackathon or prototype an idea, which is really valuable. And so this landscape is actually pretty incredible. Like there's ecosystems in crypto that don't have all these things today. So the fact that Ethereum had these in 2020, in these versions is pretty impressive. Yeah, so I got involved in like 2020, late 2020, 2021 was building apps. And yeah, I think the big thing that was missing coming from like more of like a front-end world in like Web 2 stuff where there's like a bunch of great libraries, bindings for React and building user interfaces and stuff like that was something that was a little more stable. So worked on WAGMI just as a side project. Was wondering if there was some way to standardize and make things better. So it's a React hooks library. The most important thing for me was just having robust wallet connection. Using some other tools in the past for app development, it's like, maybe there'd be a bug where you'd switch networks and then it would just randomly disconnect you or stuff like that. And that just like wasn't a very good user experience. So yeah, it like supports all the usual suspects. You can also plug in to other, you can write your own connectors and plug in there. Back in 2022 also. And the other thing too is there's just like a lot of duplication in code bases. I'm pretty sure most projects that got started like around this time would just go to Uniswap's code base, copy like all of the React hooks for like ENS related stuff, like sending transactions, signing, whatever, and just like pop them in their code base. So this like just tried to standardize like, all the features that you would want to do in your app. The other thing that was really nice, at least as an open source author, is like in the past, a lot of people would, for like more front end related libraries, would test, would like mock a bunch of the other dependencies for their tests. And so at this time, we started using hard hat forking for our tests. Eventually, we switched to Anvil, but this made it really easy to then reproduce issues and ship quickly without breaking things. So yeah, and then once WAGMI was released, we started seeing like a bunch of these pop up. Rainbow Kit, which a bunch of people here probably have used or seen before, was probably one of the first libraries that built on top of WAGMI. This is like the new modern Web3 modal, but they had like another iteration on that. Now we have libraries that do like sophisticated, like account abstraction, smart contract wallet related stuff, which is pretty cool. Improving UX. There's like lots of these. It's probably one of the most interesting spaces to look at. I feel like a lot of them copy features from each other. A lot of people create new features that are interesting. Yeah, so there's a lot of cool stuff there. So yeah, WAGMI was released, but it didn't really have any answer for type chain at the time. You could like use like WAGMI's hooks for reading from contracts, from like sending transactions, but you still had to like know what the inputs were for the contract that you'd be calling, and you could run into a situation where it like expects like a different value type, and you give it another one, and catching that at compile time was like an interesting idea, but didn't really know if it was possible. So worked on this library called ABI type, which powers all of like the type inference and safety in WAGMI and VM these days. and it wasn't actually possible, before September 2022 because TypeScript released like this specific version like a month prior, which allowed you to do some more crazy stuff with the type system. But what ABI type does is really cool. It takes an ABI. It also works for EIP 712 type data, and it's able to, like, in the TypeScript type system, then infer, like function names, event names, which is helpful. Maybe you misspelled something, it catches that. It allows inferring different argument types, which is helpful because if you forget a certain value, it will kind of tell you and warn you ahead of time. Also responses, it will do that. And it is really robust. It works really well for even super complicated ABIs like deeply nested tuples that have like arrays with other tuples inside of them, and it can pull out the different names of the properties and stuff like that. It also does pretty wild stuff like say you have two functions that are overloads of each other, depending on like what parameters you pass in when you call the function, it's able to infer and narrow the return type. So yeah, this is just like really fun, low-level thing that powers a lot of the developer experience that we have. And so WAGMI was originally built on Ethers, which was great for getting started, but for the web, which is the context that WAGMI is used in, it kind of like demanded a little bit more out of the lower level library that it used. And so yeah, Ethers is a bunch of classes, which is fine. If you like classes, go for it. I think in the context of a modern web architecture that's tree shakeable and stuff like that, having a bunch of composable functions, which you're able to like remove if you're not using them in your code, was really good. So yeah, our main goal with VM was to like kind of like have an updated library that focuses on just like the building blocks that you need. You don't have to buy in to like a specific opinions or structure for things, how things work. Most of the functions in VM and the way it works is just how it was written in like EIPs and various specs. So yeah, this was like a big exercise in reducing bundle size to try to improve websites and like push developer experience further by adding like ABI type to a lower level library. It also does some other cool things, like has built-in multi-call support. No matter what chain you're on, if the chain supports multi-call 3, that works. Also, just some other optimizations, like it uses modern contracts that Web3 and Ethers didn't use, like ENS Universal Resolver, so it is able to resolve and look up with like one RPC call instead of 3 or 4, depending on what you're. I think the mic died. Test. Oh no, I guess it's back working. Sorry, I don't know what I did. Yeah, has like built-in Anvil support, works really well for that. So yeah, if you're using JavaScript and Anvil and you're trying to like set up some tests, maybe you're running end-to-end tests and you're using Anvil as like the back end for that. You can kind of like reset the network or do whatever via VM and Anvil. So yeah, kind of like what I've been working on until now is we released like the second major version of VM and WAGMI. WAGMI was like significantly reduced in scope, so it really just is like a thin reactive wrapper around VM now, plus support for all the different connectors, which makes things a lot easier. And a lot of cases, it's like the core of WAGMI that you want to use is like the wallet connection and account management stuff. And then if you need to eject to VM, it's like really easy to do some more custom low-level stuff. This was just something that we thought we should do, was add support for another framework. React is still by far the most popular one in crypto. There's a bunch of projects, especially in Asia, that use Vue.js instead of React, so we figured we'd add it and kind of extend out into different libraries. Probably at some point we'll add a Svelte-like adapter. There's a bunch of other frameworks that maybe we'll consider at some point, but I think Svelte is next on the roadmap. VM's chain type is really cool. I guess similar to the previous talk, Alloy, where it's talking about like the network types and how those kind of like determine the behavior of the library internally. VM is very similar. It's like the chain types are kind of like an inversion of control where they can define like their own custom rules for, you know, formatting a transaction, serializing it, whatever is specific to the network, and that allows us to not have a bunch of if statements inside of VM and custom code, which works really well. We released strongly typed errors for VM recently. In the TypeScript world, you don't really have strong error types. It can be anything. It can be thrown from wherever, and this is kind of like an attempt to try to wrangle some of that, especially when you're calling RPC methods. You might get some esoteric error from a node, and we've tried to wrangle that together to make it a little bit easier to either surface that error up to a user in like an understandable way, or be able to like, you know, handle it in some more controlled fashion yourself, like recovering from it, retrying, things like that. Another cool one that I don't think a lot of people know about is you can, you know, have your own deploy list reads, either via bytecode, which I'll go over in a sec, or like a factory that's already deployed. Another really popular feature of VM is like this ability to extend VM into, you know, whatever other features you want. You can basically call client.extend, pass in, you know, some additional functions to be defined, some values, whatever else. And there's a few first-party VM extensions. We have one for account abstraction, which was released recently, the OP stack, which was a little while ago, and ZK Sync. And it's really cool. You can like build like full-on SDKs or other libraries basically on top of this. A lot of people have ones that, you know, use the internals of VM, but then expose whatever they have going on that's unique. We also have a bunch of experimental extensions under the VM/experimental entry point, which is just a good like proving ground to dump out a bunch of stuff that people might be interested in. So I would check that out. And yeah, I think kind of like what we're working on now and for the future is like making sure this stack works really well with the AlphaNet that some people have talked about over the last couple of days. And I think it's like an important component because if you know, features aren't in these JavaScript libraries, like they often aren't used by app developers. And so by connecting AlphaNet to, you know, apps with WAGMI or VM, hopefully it'll be an exciting like ecosystem where people are just trying a bunch of things out that, you know, you can send via URL to someone, they can test it out, as opposed to, you know, someone just being able to see something on the CLI or whatever. So yeah, where we are kind of like right now is we got a bunch of lower level libraries. I think, you know, there's a bunch of great things with Hardhat and Anvil where you can fork and build your dApps on top of that. I think we moved more towards like static types instead of code gen. It's just like easier to set up. It just works with TypeScript, which a lot of people are using. You don't have to run a separate CLI step. We have a few different, or a couple different front-end frameworks that you can plug into. WAGMI also works with Vanilla.js, so you're welcome to use it with anything else. We have like a bunch of Connect wallet modals. You can try out all of them. Since they're all built on WAGMI, it's like pretty easy to switch between them, just convenient. Got a bunch of quick starts and components. I feel like the hackathons these days, like people are able to move really quickly and get started just because the stack is like very obvious what you're going to use, how you're going to build things. And yeah, there's a few other things that I wanted to share. But first, like referencing back to this, like in order for things to feel alive and responsive and feel like you're connected, you know, one of the most important things is data, which is why it was interesting to see Storm's talk earlier. And yeah, like apps need data, like to have good experiences. That's like the one bullet point on this slide. And there's a few different libraries out there that I think are interesting that approach this in different ways. That are, you know, some of them are more experimental than others. One of these libraries is called Tevum, a bunch of EVM plus letters. And yeah, Tevim's a really ambitious, cool project. It does a bunch of things. You can execute an EVM locally in the browser, which potentially is really cool. Just like XXs are really useful for plugging directly into like a node, so you don't have to worry about like network and serialization, deserialization. You know, potentially being able to like execute EVM locally in the browser, you know, doing simulations and stuff like that potentially speeds things up. And also with Node or Deno or Bun as well. I think one of the most interesting features is you can import Solidity directly into TypeScript. Why do you want to do this? I don't know, why not? I'll show you in a sec. And this enables something really cool, which I think the author of this library, Will, calls bring your own view function. So yeah, imagine that you want to read the balance of a specific owner of ERC 721. In VM right now, you do something that looks like this. Pretty straightforward. You get all the type safety and stuff. The downside of this is it's 2 RPC calls. You need to get the owner, and then once you have that owner, then you need to plug it in and get the balance. Not a huge deal, but you know, imagine if you're doing this a lot in your app, or if there's like multiple steps in between. So instead of 2 RPC calls, you need to do 10 because you need to resolve a bunch of stuff, and then like, you know, mash it together. And so doing this directly in JavaScript is more expensive in time. It costs RPC credits, all this stuff. And so what you can do instead with Tevim is you can write your own view function. This one's called a void, like the request waterfall, where you batch up all this stuff into like Solidity function, and then you're able to import that into your TypeScript project via Tevim. It does like some bundling and stuff behind the scenes. And then on the second to last line, which I guess you can't, that's a bummer. So, is there any way to move up the screen? Oh yeah. That's a good idea. Okay, anyway, what is missing there on the bottom is you're passing bytecode to the VM read contract function, and that bytecode is like the compiled bytecode from the balance of owner of functions. So then you're able to get all this stuff in one RPC call and do a bunch via like the deploy list reads and calls that VM has enabled, which is kind of cool. Another project that's interesting right now, I think, is Ponder. If you haven't heard of it, it's kind of like this all-in-one backend framework for crypto apps written in JavaScript on top of VM. And it has a pretty good developer experience. You really what you do is you set up your config file, and what you want to list here is any networks or contracts and stuff you're using. And you can create like a schema for it. These are like tables, which you know, either Postgres or SQLite, whatever, the data will be getting saved into for you to query later. And yeah, maybe not as fast as like a Rust CLI, but it's pretty fast. You can just like sync up and index a bunch of data, and then there's a couple options. Either you can query that data directly via API functions that they have set up, or you can just like listen to new events as they come through, and have some like custom logic. Maybe you send out like a notification to a different service. Here we're just saving it to like a database, which you can reference later. This is all just like, I think this is friend tech related stuff. Another project which is doing some pretty cool things in the similar vein to Ponder is Mud. Mud is a project that, you know, I think is like all about high performance applications, primarily used in like gaming and stuff like that. But a lot of these concepts can also like come in to what people are working on in their like normal apps. And because it uses like the entire like stack with VM and ABI type, you get like all the strongly typed stuff involved in there. One of the really cool pieces of it that's unique is real-time updates that you get. So similarly to Ponder, it's like you kind of define your table structure and set up you create some like methods to call into here. This is just for like a simple counter contract. And then you have a component where you can just like read directly from that value, and then it updates in real time behind the scenes with some of the infrastructure that they've built. And this is incredible because, you know, front-end developers and I think more JavaScript developers in Ethereum kind of like span like the gambit in terms of experience level. Like some of them are super knowledgeable about Ethereum. They've been in the space for a long time. They've used a lot of the tools that, you know, listed out before. And some of them are a little bit newer. They're interested in the space, but their like skill set is building user interfaces or something. And it's not really about like how to index data, how to query it, what the most efficient way, or like what RPC methods should I use. And this is really cool because you can get real-time updates from the chain just by, you know, calling a React component and having that set up. So yeah, that's kind of like how the landscape is laid out today. And yeah, I think we're in a pretty good spot right now, but going to keep pushing and see what else we can come up with. That's it. Any questions?
Hi, thanks for the talk. So you mentioned how like real-time data and responsiveness is important for the feel of these applications, and how VM's optimized for things like tree shaking to make the bundle faster. Have you looked at all at using like WebAssembly either for the core parts of VM or for porting Anvil for local simulations at all?
Yeah. Yeah, we've looked into that a little bit. Last year, I gave a talk that was kind of similar with like trying to bring in like Rust into the JavaScript world, and I think it's really promising. I haven't like checked back in on like what the current state of things is then, but that whole thought was like, the things that people use via TypeScript that's really valuable is the types. So it's like if you can write the types in TypeScript and then you can have the runtime be something else that's really fast, then you could potentially have like an incredible developer experience. Yeah, and I think combining those two things together is a little rough. And one of the biggest issues right now is that the bridge to Wasm, it like takes a decent amount of time. Also, when you're first like downloading the code in the browser, it can be a little heavier. And like usually a lot of the stuff that you're doing, maybe if you're executing stuff in the browser directly, you don't run into this, but a lot of the things with like JSON RPC calls and networking and stuff is the bottleneck anyway. So yeah, I think there's probably going to be some interesting stuff there soon, for sure.
Great talk, thank you.
Thanks.
The Tevum example that you gave, the TEVM, the balance of owner of function, how is that different to a deploy list call, where like you would do an ETH call on chain with the with like a state override where that contract is deployed? Yeah.
I'm not 100% sure. Yeah, like how it would be different. That's a good question. Yeah, I need to look into that.
Or maybe it's just the same.
Yeah, I'm pretty sure it is. Yeah, because like you're just getting the bytecode, passing that in.
Yeah, but a better.
The difference probably is that you do the simulation locally versus on the node, right? Like when you do the ETH call with state override, the RPC must support state override, which some do not actually. And when you do it, you're actually running the compute on the server, whereas in the Tevum example, the EVM runs locally.
Okay, yeah.
So it's not doing an ETH call in the Tevum case.
Yeah. Okay, cool. Thank you.
Hi, great presentation. I was just wondering what your take was on how web development is sort of progressing with like more Rust frameworks. Like, I don't know if you had a chance to look at Rust frameworks, but if you had any like thoughts on that.
Yeah. I mean, it is interesting. There's definitely a lot of potential benefits for like performance-related stuff. Yeah, like I talked about it a little bit earlier. I think a lot of it is just around developer experience. It's not great right now because it's on the bleeding edge. It'd be hard for like most people to, build an app using something like that, but I think it's probably coming. Even just stuff like rendering the DOM faster, you can potentially speed up a lot by like using Rust.
How do you see the future of front-end development in the sense that is it going to be like fully powered by kind of indexers, or it's going to be like a mix of RPC and indexers, or just some maybe more powerful RPCs or something like this?
Yeah. I'm personally really excited about like potentially people being able to run their own nodes and indexers and stuff and make that more easy with like ref and things like that on the horizon. Just because like I feel like most organizations, once they reach a certain scale for their apps, it's like really hard to rely on RPCs to get what you want, especially when there's like the trade-off with costs and whatever. So I think like the closer you can get things to like your own services seems to be pretty good. I think there's some like client stuff which could be cool that I don't think has been experimented with a lot in the browser. But yeah, I feel like a lot of these things is just like, you know, if you're interested, if you want to reach out to us and you want to like explore with us, we're happy to. But I think there's like so much opportunity just to like work on, you know, new projects on your own that push this stuff forward and then get it in front of people, because people want better solutions than just querying their RPC and mashing the data together. Sick.
Okay, next up we have Brian from Base talking about ref benchmarking.
All right. All right. Thanks, everyone, for coming out on a Saturday. And I know we're getting close to lunch, so probably getting low on